Okay, hi everybody. Seems like we have 15 people here, which is awesome. So this is my first time doing Twitch stream, so I'm probably going to be working out how things go as I go. If you can hear me, could you just comment maybe something in the chat just to make sure everything's working all right? I've got my like management window down here in the right, so if you see me looking off over here, that's what I'm doing. All good, nice. Thanks, Mukesh. And Steve, cool, awesome. So thanks everyone for joining. This is great. I'm really excited by this. It'd be awesome if you could, anyone who can introduce themselves in the chat. It would be great. I'd love to know, what things in particular you're interested about learning today. I'll kind of just do a little bit of intro to things to get us kicking off. Make sure everyone gets a chance to join. It looks like we probably have most people here already. But yeah, what brings you to the stream? What things you're interested in? I'm going to be walking through the kind of recent Oso Go integration, diving into some of the code of how that all works, talking through Oso a little bit and why you might be interested in using it, but really focusing on some of the implementation stuff. I think that was the kind of core piece that we were talking about today. Maybe get a chance to dive into how the interoperation works between Go and Rust. I think that's a potentially particularly interesting piece. And yeah. Eamon here. Hey, Eamon. Excited to learn about how you're thinking about design decisions. Yeah, I will definitely have some time to talk about that. As a giant caveat, I myself am not I'm not a Go expert by any means. This was kind of my first serious piece of Go code, so there's likely to be a lot of non-idiomatic things going on. We roughly followed the structure of some of our other libraries, so you'll see some of that coming through. Hey Adil, CVP dev, interested in Rust Lang authorization. Perfect. So yeah, I think you're in the right place. We don't yet support C++, which would be an interesting one maybe to do shortly. I think that would have probably a similar-ish integration path as the Go integration here. I've done some C++ and Rust interop before in the past that worked really well, so I think that'd be quite a nice integration to add. Yeah, we can see the C style API that we expose from Rust, which is how we kind of do a lot of our language bindings that something like C could just use directly. But we typically add on top of the Rust library, we have like a little layer which does in the host language, which handles some of the like actual authorization pieces and type management, things like that. All right, I'm just going to dive in then. It seems like the viewer count is roughly stable. So let's get cracking. Okay, so to start with, oh yeah, and thanks to my wife Yaran, she's brought in my tea. I'm gonna kick things off nice and traditional with English breakfast tea. I think as we do more of these streams, I'm gonna have to get a bit more exotic. Well, I will say, we did end up getting like an entire crate shipped from the UK just so we could get some proper English breakfast tea from the UK. Because I don't know why, but even though like identical brands of tea in the US and in the UK, they just taste completely different, and the packaging looks off. So I think there's like some non-legit tea making thing going on there. So yeah, get your English breakfast tea from the UK. That's my advice. All right. Okay, so to start with I'm gonna like just give we have this like kind of typical quick start sample application that we always use for sort of showcasing OSA, and that's what I'm gonna start with today. So I'm gonna share my screen. Okay, so here we have and yeah, let me know if the resolutions or the sizing is off. I can zoom this in a bit. Make it a little bit clearer. So okay, so I'm in this server.go file. It's a very simple little HTTP server. You can see it has this kind of this one method serving HTTP, where it's doing some very basic raw. Cool, thanks, Clinton. We've got some very raw and basic HTTP handling with like splitting the path by // and pulling out the segments. And we've got this like this line here where we're checking if the resource is expenses. So basically it's a, it's a web server. It's expecting to get requests coming in at like /expenses. It's gonna get an expenses from like our application has like a little stored array of expenses. It's gonna pull the user from the header, not doing authentication properly here, just pulling it out of the header, completely untrusted. And here's the call bit, right? We're calling into the app's Oso is allowed call, and we're passing in the actor, so the user pulled from the header, the action, which is the method on the request, and the expense which looked up. And this here is like the core, the crux, the core motivation of Oso is like you have your application set up. It can be handling requests and all that, and wherever you need to make an authorization check, is the user allowed to do this thing? You just call out to this method. All right, and this could, in this case, we're being we're specifically passing in the expense, but we're being so we're doing this over any action. We're just passing the method as a string and saying, are they allowed to do this method, get or put or something like that. And then the idea is that the Oso app, when it's making that decision, is this allowed or not, it's going to be checking policy files that were loaded in. So in my like app setup down here, I'm loading the policy.polar file, which right now is empty. So let's just have a look at what happens. Let's make this nice and big. Run my code again. All right, so if I go and make a call request to localhost 8080 expenses 1, then I get not authorized back, right? So this is coming from, if I switch back to the code, you see I have this pretty basic check where if alloved's not returned, then I'm going to return unauthorized. Okay, so what's happening here is Oso made an authorization decision. It decided this actor is not allowed to get the expense, and that's because my policy file is entirely empty. So Oso is denied by default. We haven't explicitly allowed anyone to do anything, so no one can do anything right now. So let's go ahead and change that. I'm going to just add allow, and I'm going to take in an action, rather an actor, an action, and a resource. I'm going to like fly through some of this a little bit quickly because I think some of you are probably already more familiar with Oso and Polar and how this all works. Just let me know in the chat if I've zoomed through something too quickly and you want me to like kind of slow down and explain something. So these are the kind of the format of the rules. The is allowed is kind of by convention looking for this allow rule. You can actually write other kinds of rules and query those. I can go through that later if people want. But the main thing is, I take in these 3 inputs, and what would follow is the conditions for which I want to allow this request. And so I can say if true, so everyone is always allowed to do everything. I can actually shorten this. I can just put a semicolon and say, this is just a statement of fact. An actor is allowed to do every action to every resource. And when I say for every, actor, action, and resource here, they're like input parameters. They're like variables. And right now they're just matching anything. So there's a lot of like pattern matching kind of thing going on here. Maybe I'll try and do this as a split screen. So if I go and restart my application, once it loads up, you see I make this request again, and it's allowed. So I get back this like go printing of the expense. So cool, everything's allowed now. All right, that's not very great. So let's start getting into like the core of what Oso can really do. So importantly, you can start matching on some of these inputs. So maybe we want to say that the resource is actually an expense, and we can add these type checks, which we call specializers, to say this expense should be an expense object as Go understands that. Right. So as we saw in the application code, we called is allowed, and we just passed in an expense, which you can kind of see my Go IDE integration here. Knows that expense is an expense. So similar mechanism is going to be able to check this in the policy file. And I might want to do something. I want to do something with this actor input, which we're actually getting in as a string. And I want to check that, let's say the actor is in the right company, so they have the right domain or something like that. So I can do actor ends with example.com. I think that's the right thing. Oh, waiting for this as well. You can actually see there's we're getting some nice warnings here from Polar telling us that we've defined some inputs, but we haven't really restricted them or used them. And this can often be a sign of a bug. So you can put an underscore in front of a variable in front of a parameter to say, it's okay, I'm intentionally not using it. This is sort of allowed for any expense. All right, and now that I've done that, I can continue to get expenses if I'm alice@example.com, but if I was alice@foo.com, then it's not authorized again. Okay, because we checked that the actor as we pass it in, this string ends with example.com. So if you're more familiar with Go than I would, then you'd probably know that this ends with doesn't actually exist as a method on a string. So this is where some of the details start getting a bit interesting. So through this integration, we're actually making methods and things like that from Go available to the policy, and that's gonna be the core piece of what I'm gonna dive into later around showing you how this is all hooked up. So I was a little bit sneaky here. What I've actually done is I've made this user type, which is just I'm actually not sure what the correct term for this is. A type alias is what I'd call it in Rust, or a new type or something. So the user is just, I have this user type, and it basically is just wrapping a string. And I've added a method to it, so to kind of extend the functionality of string to say, to implement this ends with method that will use a built-in Go package has suffix to check that the user, when treated as a string, ends with that pattern. So this is how I'm calling it. But so when I'm doing in my policy, I'll just type it above here, right? I had actor.ends with, and I wrote a string. So what's happening here is we're picking up that the actor is actually a user. That's how we pass it in. Actually, if down here you can see I wrap it as a user. We're looking for this method ends with on it, and potentially calling it with a string that I wrote and defined in the Polar policy, right? So there's and this really just captures the core functionality of what we're trying to achieve is things like I can do type checking, is this thing actually an expense? I can call methods. I can do comparisons on stuff. So I could, maybe this is too broad. I actually only want users to be able to see their own methods. So I'm going to actually say, one sec, I was going to record. So I want to check that the actor is equal to the expense. Oh, this is my favorite thingy bug. Maybe the expense submitted by field is equal to the actor. So now I don't want to ignore the expense anymore. I definitely want to use it. And the submitted by fields, that's coming here off the expense, which is also a user. So I make that change. Again, let me split my screen, restart this server, and once it runs, okay, cool, let me clear that. So if I try and get expense one, wait, what is not working? We have a problem. Expense submitted by is actor. So this was working when I tried it earlier. So what did I do in the meantime to break things? This is gonna be fun as we'll trying out what things are working in the alpha version of this Go one. Huh. Oh, I'm still sending the user as alice@foo.com. Well, that was good. All right, there we go. We're back in business. So 1 and 2 I can get, 3 is not authorized. Yeah. Thanks, Steve. Yeah. The saving I think is just the comment I added, so that shouldn't be changing things. But Steve in the Steve, you're right. I was looking for foo.com, not example.com. Cool. So you can see my authorization is actually working pretty well here, right? I wanted to check that the user could read the expense, and only the correct user is reading at this point. So there's actually something a little interesting going on here, which is I'm using this equal method that I've defined. So I've kind of told, I've implemented a sort of a method here to allow me to be able to compare users together. And this is, again, like another one of the sort of built-in things we have from the host language, which is kind of a little different, a little unique, like language to language. So this is kind of another detail we can kind of dive into in a bit. But so the interesting thing is we're reading the submitted by, sorry, one. Sorry about that. Yes, we're pulling off the submitted by field off of the expense. The submitted by field is a user, and so we're able to check it against the actor we pass in. Something here a little interesting as well. We're checking the actor input as a string, but I just showed you, right, that it's actually wrapped as a user type. And so, in this we kind of have, some basic amount of kind of like inheritance type checking, where you can check that the user is like of the same type, not necessarily identical. Which honestly, when I started this morning, I wasn't sure if that would work or not. This is kind of all some of the new stuff we're doing in the Go library. Sorry, cut out as user type def. Yes, I believe that's the right term for it. All right, so that's the motivation. Would anyone like me to dive into anyone want me to slow down and explain any of the stuff that's happening here, kind of talk through it, or should we see what's happening in the Go code? I never know how long it takes the have you written any tests, please? Called out, nice. Not for this example. No, definitely should have done. The test for the core library itself is kind of an interesting subject we can go to later. There's kind of plenty of tests in here. In the Go library itself that we're checking for all the various different functionality that can happen. The reason that's kind of an interesting topic is so right now Oso supports like stable versions, release versions, Python, Ruby, Java, Node.js, and Rust. And so across those 5 libraries, we're now adding Go. Across the 5/6 libraries, there's kind of a challenge around keeping the code in sync. Like we sort of very rarely make changes to any of the core language API stuff, but if we do, it's kind of, if we want to add a functionality, you have to go and add it to every library, and then we have to test it in every single library. And when you're developing, that can be really painful. So one of the things we were investigating with the Go code here was having a way to write tests that could be kind of implemented across any of the libraries. So what those look like, for example, is we have like some basic tests here defined in a YAML file. Here's a super basic one. We have like a YAML spec that asks for the query you're supposed to run, the result you're expecting to get, and can go more complicated and check things like you can query things with integers, strings, booleans, all these. So the idea is that we define each of these test cases via these like YAML specs with like a little test runner in each language that can actually make sure they all stay in sync. But we can dive into that a little bit more later. All right, so I'm just gonna like walk through effectively what's happening from this like Oso is allowed, and like trace through the sort of life cycle of this evaluation being made. What's that gonna, is that gonna be, that's a sweet. Okay, so we call this allowed. Actually, let's take one little step back and just see Oso get initialized. I think that's important. Oso gets initialized, so we create a new Oso instance. What this is doing is creating a new polar instance. So the way we kind of generally refer to things is no problem. It was a great question. Oh, were you asking about have we written tests in the polar code? We can come back to that maybe. So we have this naming convention, or the way that we refer to the components is there's the polar language. So I'm writing my policy files written in the polar language. There's the core implementation of the language of Polar, which is the piece like written in Rust. And then so the libraries, which are the things that allow you to add authorization to your app, those are the Oso libraries. And so basically each Oso library is in some ways a relatively thin wrapper on top of the very powerful language where like a lot of the work is going. So we create a new Oso, we instantiate a new Polar. You can now start seeing some of the FFI stuff happening. So we're creating like a new Polar FFI, instantiating that like internal Rust. It's actually a language VM. So we're creating the Rust object underneath the surface, but it's all been managed on this side of things. It's kind of managed by this opaque pointer. So that's kind of going on here. Then we're registering classes. So if we want to use something like an expense as a type check, as a type specializer, we need to let Oso know that expense is a thing that exists. So I register a class here, and what that means is I can use these like type checks here. If I hadn't have done that, I can still like read attributes and do things like that with it. I can still use them in policies, but I just can't use them as those explicit type checks because this is effectively the policy code is looking for the class which is called expense. Sorry, yes, FFI is an acronym for Foreign Function Interface. So I'll spend a bit of time going more into the details of what's happening at this foreign function interface, this FFI layer. This is kind of where this is the the interface between the Go codes in written, the Oso code written in Go, and the Rust code for Polar written on the surface. And yeah, thanks Steve for answering that as well. All right, so now we have our Oso instance. We can do things like load policy files. I'm going to kind of skip over that a little bit. Okay, so going back to the Oso. Okay, so now we have an instance of Oso. We've stored it on our app. We can make these is allowed calls. So diving into that, this takes in these three inputs: act, action, and resource, like the way I wrote that in the policy. And these at this point are just treated as just generic interfaces, so they can in Go, this is kind of saying effectively it can be of any type. We don't worry about the type. We just want to treat it as just some kind of dynamic object effectively at this point. And so you can kind of come in as any type, and then we kind of query the sort of the actual Polar thing. It's this OP thing. You'll probably see this around a lot. It's we have the Oso objects. We're looking for the pointer to the Polar objects inside the Oso objects, and that's where like a lot of the functionality is sort of actually happening. Okay, cool. So we're gonna, and this is basically what you're seeing here is when I said that allows just a convention for this is allowed interface. It's basically this line here. So you can effectively always query anything that you write in the policy. I can write like my hello Twitch rule. It just takes in I know message, which is a string, and if message equals hello or something, and I could query that using that query rule interface. It doesn't always have to be around this allow, but in the context of authorization specifically, having this sort of single entry point for allow is kind of a very convenient way to set that up. And that's really what I mean when I say Oso is kind of this somewhat like thin wrapper over the language. Is really we're just calling this like allow, and a lot of the work is happening inside the language. All right, so going another level deeper into query rule. Now we're going to start getting into some of the real meaty code here. So now query rule has a little bit of a different setup than is allowed. It just takes in sort of any number of arguments and the name of the rule you're trying to query. So the is allowed, the allow rule, or the what I call the hello Twitch rule I had before. That's the string name that it's going to try and match. That it's kind of calling like a method. But it takes in any arguments, and it's basically going to go through and convert each argument into a representation that Polar is okay with. So here we're sort of hitting one of the first like real kind of interesting details of how this is all going to fit together. Is I can pass in any type. It can be a string, a number, or it can be as a sort of like an expense object, and we need to be able to convert those into a way that the Polar language can deal with. And again, the Polar language doesn't know anything about the host language. And just to clarify, I'll say host language a lot. Host language always refers to Go or Python. It's it's called the host because it's it's the one that's running the code. It's kind of it's where everything is executing, and it's sort of where a lot of the stuff is taking place. So yeah, so we need to be able to convert any type we give it into something that Polar can pass around, understand, operate on without needing to know specifics about it. And so what that looks like is something like this. So we take in any type, any interface, and we're basically going to have this nice big switch statement over the type of that. And so in the case where it's something relatively simple, like a Boolean or an integer, we can convert it into our like the appropriate Polar value variant. So a value Boolean, we have like value numbers, we have value string, things like that. Those kind of types that are understood sort of natively inside the Polar language. It can like operate over them without necessarily needing to like go back to Go. Just give you an example of that. I'm going to run the REPL for the Python one because we haven't implemented this in Go yet. For example, so this is me now. I'm now writing Polar queries inside Python. I can write things like x equals 1 plus 1, and I get back x is 2, and that'll happen inside Polar, right? So Polar knows what integers are. It can add them. I can do things like C in ABC and like iterate through characters in strings. Again, that's like happening inside the Polar language side. So when we convert some types from Go into the Polar, we're not always going to just treat them as Go types. Sometimes we'll actually want them to be treated as an integer or string. Then for like the more complicated types, well, we have things like lists get converted to list and maps get converted into dictionaries. But really, this is kind of one of the interesting ones down here. The sort of default case, like this is like the full through case for any type that we don't want to handle, that we don't want to sort of like try and convert or natively pass into Polar. We kind of cache it, which is like we basically just store it inside in the Go side and just return like an integer identifier, this instance ID. And that is what we're going to pass back to Polar, is just this ID. So inside the Polar code, it's just going to be like dealing in these like opaque instance number 5, and it doesn't know anything about that. So when it's passing around this expense, it's just an instance number 5, and that's all it knows about it. If and anything it wants to do on that instance, if it wants to check what type it is, if it wants to compare it to something, it's basically going to go back to the Go code, back to the host, and say, is instance number 5 an expense, yes or no? And this is kind of like the crux of how we're able to support multiple languages. Is we design the language to just be happy to deal in these generic, these arbitrary instances and just pass them around and operate on them. So this is kind of one of the core pieces. As a quick little sidebar, because I mentioned earlier about maintainability between languages. One of the things we tried in this. Let me go to that one. One of the things we tried in this library was we sort of had all of these possible types that can cross the boundary between Rust and Go to be generated by some code generation, and to in particular to do things like define how it to serialize and deserialize from JSON. So if you see me like talk, I'll be passing around some of these terms or values, which is a value variant, things like that. These are all coming from the code gen, and you can see these are kind of done by matching on the representation we get back. So it's kind of a lot of the conversions happening here. Okay, but that's where like these are coming from. The definitions of these types, they're actually being generated from the kind of definition of the Rust types. All right, so okay, so that was a little dive into how we're doing this conversion. And basically the main thing from here onwards is we're now constructing a new query. So we've converted our input types into ones that Polar can work with. And now we want to make a query. So what making a query really means is, if you're familiar with logic programming at all, or there is this concept of a unification, which is, it's really like pattern matching. So to show you what I mean by that, I'm going to go back into my REPL. So these simple operations like x equals 1 plus 1, it's sort of actually a pattern matching operation. It's not, I haven't really assigned to a variable or anything like that. I've said I have a variable x and it matches the expression of 1 + 1, and 1 + 1 we actually matches 2. Sweet Prolog has never heard of logic programming. I think I know who that is, and please don't kill me for calling it pattern matching throughout. But so like to give you an example of what's kind of going on here, I can do things like I can take a list of variables like x, y, and z, and I can unify that, so I can kind of match it with a list 1, 2, 3. And I'm going to get back somewhat unordered here because it's stored in a hash map. X is 1, y is 2, z is 3. Right? So I haven't, and this is effectively gone element by element and matched them. And I can sort of mix and match these in weird ways. So I could just say, x2z matches 1, 2, 3, which is fine. X is 1 and z is 3. If any of these fail, then just the result is false. I can kind of go in both directions, right? I can say x2z matches 1, b3, and get, as you expect, x is 1, b is 2, z is 3. So that is like a 10-second crash course into like unification and like logic programming. Is it's doing this like matching thing. Now, the reason I was talking about that is because the way that rules work is no different. So when I have a, where's my policy go? When I have a policy like this allow rule, to query it, I basically write something like, this. This is sort of what's happening. Get, and then I don't actually have an expense object in my hand. This question mark equals syntax here you can run these like inline queries in a policy file so that it yes, thank you. Logic programming finds solutions that make things true. That's a great explanation of it. This is where I really don't want to be able to hand over to Annie and let her take it over from here, but so we're asking this question, and yeah, as Sweet Prolog here said, what are things that makes this expression true? And so imagine I actually had a expense object in my hand here, which I can't construct from the poder in this way. So it's going to match this rule, this thing with all the rules it finds that matches that. And so I can have multiple of them. I can have ones that just match anything, and so on and so on. So it's going to look, so okay, what rules do I have that match this allow? So looking them up by name, what rules do I have that match these by input type? So yes, this is looking for an active variable, which is a string. Like that is fine. What actions do I have that match get? Well, everything matches action. But if this was get, again, it's going to match get and get. That's fine. This is what things do I have which are expenses? Will that match? Is that okay? There is like one thing here which is not necessarily something you can also do. Sometimes is useful in authorization, which is these aren't strictly just input types. You can actually define what values they could be inside the body. So if I was to write this as allow alias action and expense, and I had get here, this might return this is true when action is get, which is something it's kind of like an interesting way you can use it to do things like find all the actions someone can do. All right, so what that means for our implementation back in PoloGo is we're constructing this query from the term, and it basically looks like this call because that's the thing we're matching. So we're basically going to pass it in, something matching with name, allow, and with the arguments we converted, construct a query from that, and we get back this query object. And so this is where the sort of actual the query is where the execution really is happening, as it's kind of like going through. Yeah, this is where things start getting complicated. The sort of the execution model here. Maybe I'll dive into query to show it. So the execution model is we kind of create this query object, and we're effectively calling this like next method again and again on it to make progress. And you can see this is in like a for loop, and the for loop is continually calling FFI query next event. So basically the model we have here is you construct this query object. It represents like the evaluation of a query inside the language, like the execution of it. Imagine you're like mid method call. And the language is built like a virtual machine, which means you can do things like you can pause it and resume it, which is a very important implementation detail for us. Because as it executes, it's gonna make progress. It's gonna do all it needs to. You know, if it needs to add 2 numbers, it'll add 2 numbers. If it's gonna compare things, it'll compare them. But then it gets to a point where it's like, I don't know the answer to this. You asked me, I need to check instance number 5, is that an expense? I can't answer that myself as the polar in a language. I need to ask Go. So I'm going to pause where I'm at. I'm like midway through evaluating this query. I'm going to pause and return this back to the host language. This is like a really important execution model for us because it means that all of the control is on the Go side. So this next loop here, all the progress is made by Go. It's the one driving things. So it calls next event, the language does some progress, if it returns, control is back in Go. There's not like a background thread, there's not some outstanding channel it's waiting on to listen or a mutex it's locked on. It's just purely in Go's hands at this point. If it needs to go off and, I don't know, make a database call or call some other service or just compute something heavy, it's in Go's hands. We're not like assuming anything about the runtime. So for example, in like node land, lots of things are written with like async await. That doesn't matter. It can go off and async something, and the Polar VM is like pretty happy sitting there and not consuming resources. Okay, so this interface, this next event is sort of everything's happening. This is us saying, I have a query, make some progress. What do I get back? So to see that, I'm actually gonna, so first what I'm gonna do is, let's print out what we get. Format, printf, I think will do the job. I think I want it to be that. Let's see, how's my Go? All right, we're gonna get, these did not print out as nicely as I was hoping. I should probably add a new line somewhere. I thought this was like supposed to be pretty printing. If anyone knows how to make it do line breaks, that'd be super helpful. My Go does not extend that far. All right, cool. So okay, this is hopefully clear enough if I zoom in a bit. So these are the events we're getting back from the VM. You can ignore this. This is because we are just doing a. You can see we're doing like a little test query at the beginning to check that we can do hello. Okay, but yeah, here's where the magic's really happening. So for example, look what we're getting back here. It's kind of a lot of query event verbosity here, but if you kind of trace through, wow, okay, it actually is instance number 5. That was just a random example, but there you go. Here's instance number 5. In this case, the tag is looking for a string, right? This is matching with the fact that we passed in a user. Up here, we passed in a user, and it's matching against actor string, right? So you can see this is where it's doing this like little evaluation. Okay, so instance number 5 is string. What about instance number 6 is an expense? And we expect these are both true. Further down, we're seeing things like we have a call. So this is where we're trying to read values from Go, and we're looking for the attribute submitted by, and again, it's on instance number 6 in this case. We have external unify, so that's where we're checking equality of the submitted by and the actor we have. That's where the equality happens, and then we're done, right? And so down here we get back a result, and you might end up with some bindings. Yeah, so when I said if I queried it with an action variable, I might get back action is get. That would be returned in this result, but we're not using those in this case. So you can see this is the conversation that we've just had between Go and the language. And so basically, it's getting back these events. Anytime that Go needs to do something, it's returning control to Go, and it can evaluate them. So this here is actually like a really useful, powerful model for us, because we just need to. So the implementation burden for us in every language is like, can we handle these events we're getting back? And so that's kind of what's happening down here. We do a switch on the type of the query event. And for example, in the case of, let's say the external ISA, so this is the type check. We call it the handle external ISA event. We use the host to do an ISA check. So this is, we're just kind of in the query shims, effectively shimming out to our implementation of the host. And so we're going to do an ISA check. So it takes in a term, so that's like a polar value is coming from polar, and we have a string we want to check it against. We convert our value back to a Go type, so the reverse of what I showed earlier. We're getting a class by tag name. So when I did register class expense, that's going to be stored under the name expense as a string. And then we're using the Go reflection here to check the type of the instance matches. And this host, so this host.go file really captures like all of those kind of operations. Everything where we're requiring the host language to do some processing for us will kind of happen within this. And so Unify has the equality checking. We should have, actually, we maybe didn't split these right, but if I have my call logic, actually it's happening in the query body, we should probably refactor this out and put it out. That's where we're looking at methods by name or like looking for attributes, things like that. And so this is a kind of the interesting piece, is that like in every language library, we've effectively had to implement some form of this kind of like reflection interface. In Python is like very, very dynamic language, so this is like very easy to do. Python doesn't really care if it's kind of, Python expects to be run this way anyway, so these are easy. In something like Go, which is kind of more statically typed, then you sort of need to use some more of these like reflect style interfaces. As you can see, it's actually not too bad. Where this was really challenging was in Rust, which has no concept of runtime reflection at all. So we had to basically build all of this ourselves from scratch. This reflect package is in the sort of core Go libraries, core Go packages, and kind of just about did enough for what we needed it to. But you can see, for example, in the case of the handling external calls, so looking up attributes or calling methods, it's a little bit more involved. So we're having to do a lot more things here to make the method calls work, because we have to convert all the types. We need to check how many input arguments we have. We need to Go support things like variadic arguments. So if you write a method that can support multiple input types, we need to check that and do the kind of conversion stuff. But this is all happening through this reflect interface. So here you can see I'm doing things like I'm checking the type of a method. I am checking how many input parameters the method expects. I'm checking if the method is variadic. Like, luckily it supports all this for us. So we're just interacting with this Go reflection to make these work. Yeah, so that's kind of the main bit of the reflection stuff. I'm going to go and talk about the Go Rust interface, the FFI, the foreign function interface between Go and Rust now. But before I move on, let me know if there are pieces of the reflection bit I can dive into. I'm gonna drink some tea in the meantime. And this method's horrible. I'm gonna leave the screen on a nicer one. I like this check. This is a pretty clean one. I guess this line here, 121, is this is why I could consider a user as a string. And we're releasing the Go library in alpha, sort of today or the next couple of days, because we still basically want feedback on some of the design decisions like this. So, and which kind of segues me back to Eamon's question earlier around design decisions. Some of the challenges here is we sort of have our like language semantics of how the Polar language kind of expects to work, and then there are the semantics of the host language like Go or Python or Java, whoever it is, and we sort of need to be consistent across all of them, because the expectation is that you can pick up, once you've learned Polar, you can use it in any language library, and it's going to be like a similar experience. maybe keyword arguments aren't supported in Go, so you can't use those like you can in Python, but you shouldn't kind of expect to. So what about, in this case, right, what about a type check? So the semantics we have here for these type checks, these type specializers are, it must be the class itself or a subclass of that that you're checking, right? Yeah. And which this can be incredibly useful because you maybe have a like base object type and you want to have an authorization rule that applies to all objects of the same, like all of those base object types. So that then you can just write a type check for like base. But then you want to have like a specific rule which is like more precise for an expense. So you write a different rule which has the expense type in it and things like that. So that's kind of like how we want the language to work. But then we have these decisions around how does that model with what people expect to happen in Go, for example, and like what's the best way to represent that with what we have. And so, for example, here I've used this convertible to as a sort of maybe a lightweight version of that kind of like inheritance structure. Like if we could explicitly check that the type was the same type you're expecting, so it can only be a user, not a string. For me, that's too limiting. It doesn't kind of reflect what we want it to be. But in Goland, maybe the kind of like subclass inheritance thing isn't quite the same thing you're expecting to see. Like maybe that would be more closely related to things like interfaces, which is kind of another whole design decision. And so I think, for me, what we would probably want to aim for is the sort of method dispatch, rule dispatch should be roughly in line with how a host language would dispatch. Like if you can call a method that expects a string with a user, then you'd expect that rule to match. And I think that's roughly what we have here. I think this convertible to is the same kind of mechanism that Go would use to check if you can actually, you can actually call a method with that or not. Someone correct me if I'm wrong on that one. Okay, so I'm going to go now into like the final layer and talk about the FFI interface. So there's a bunch of different FFI methods. If I go into the FFI.go file, I can kind of pull up my list. Like you can see I've got a bunch of these different methods here for the Polar FFI for things like constructing a new query from a term, for registering a constant, for loading a policy file, and similarly for query. And these kind of all take a similar shape. And this is kind of part of the kind of easy part of the implementation is we pass messages back and forwards across this interface as JSON. So all we need to do is at this layer at least, is get back the string from calling the library. And I'll go show you where this is happening in a sec. We basically get back the event as like a C style string pointer, and we convert it to a Go type. It's pretty straightforward, and that gets returned, and we saw before, DCIs from the JSON. So what are all these? What are these C dot blah, like C dot polar blah, C dot blah blah blah? This is where we're calling into the Rust library, and we're using CGO, which is like Go's support for calling C libraries and things like that. I'm a little suspicious of Go's decision of how to do this, but I will admit it's very, very convenient compared to some of the other languages we've done this for. You like import C is kind of how you kind of are importing that C library and the package and stuff like that. And then the comment here, the like doc string, is actually defining the linking and the where to find things like the header files, which I don't know, I find a little funny, but it is very, very convenient and easy to see what the hell's going on. So you can see, for example, we're including some standard library things, and we're including a Polar header file. We'll see where that gets generated. And for Linux, for example, we're linking it against a statically compiled libpolar.a. All right, so where are these coming from? These are coming from, actually, I'm going to open a new folder to do this. Oh, it's on a different screen. So this is so I'm now just in like the core Oso GitHub repo. You see we have these like Polar these various different Polar folders inside the main Oso repository. Polar core, this is our like Rust project. This is where all the Rust code is written, the virtual machine, things like that. Then we have this Polar C API. This is basically just where we have like this another very, very small shim layer, which takes the Rust code and how are you using it via built-in static objects? Yes, I'm sorry, I'm not entirely sure what you mean by built static objects. But I'll show you how we're exploring the functions. This is all happening in this Polar C API. So what this looks like, so this is still a Rust code, but it's Rust codes using Rust's like ability to expose C compatible interfaces, C compatible functions, things like that. So let's take a really simple one, Polar new. So remember when I've shown instantiating Oso, the first thing I do is create this like pointer, this opaque pointer to the Polar instance. This is happening here. So this is a Rust function, Polar new, and it's returning a mutable pointer to a Polar object. And there's a few things going on here. So extend C. This is me saying this should be exposed as a C interface for any sort of like any compiled artifacts you're creating. There's this no mangle at the top, which is basically instructing Rust, don't try and do some like how you linking Rust and Go. Yeah, I'll get to that in a sec. We'll trace it through on this. The no mangle is basically saying don't mess with the name, don't try and be clever and make it so that it's like doesn't clash with names, because Rust itself will like turn the function name into something which doesn't won't clash with if you happen to have another project with Polar new. But I'm saying no, I want to call the function as Polar new. We have a build script which is using this amazing Rust project called cbindgen, which will basically take in everything I defined in that lib.rs, all those functions, and convert it to a header file, a C header file. So this is outputting all like the definitions for everything that is accessible from the Rust library. So again, here's my Polar new, right? So it's just takes in nothing, outputs a pointer to Polar. You can see it's doing some of the type defing here. And then in the Rust like cargo.toml, you can basically tell Rust like what kinds of artifacts to create when it builds. So here we're saying, for example, output this as a static library, like a .a file, or a dynamic library like .so. And if I go into like my target and look at like the Rust things that are built, you can see the various stuff that's been built here. So I have my libpolar.a, I got my libpolar.so. So there's my static Linux one, there's my dynamic Linux one. So these are this is my compiled Rust codes as a static library, so with like no dependencies on any of the system C stuff. And I have my header file. I am now ready to embed, this is now basically a just completely C compatible project. Like people don't need to know that it's Rust under the surface. You have a header file and you have a static library, you're good. And so that's what we saw at the top of the file in ffi.go, which is in the other window I'm in. That's what these things are linking to. So we basically copy that static library into a directory. Here's some system libraries we need, right? So we're linking against libpolar, the static library libpolar.a, and we've got all those definitions from the Polar header file. Sorry, can you go through export code quickly? My internet went out. Yes, I'll quickly run through that again. I'm getting short on time here, so I'll sort of zoom. The crux of it is this Rust code says like basically make these methods Polar new available to any compiled artifacts. In my cargo.toml, I'm saying compile it to a static library and a dynamic library. So in my output files, I can see like a libpolar.a, libpolar.so files. And we have this cbindgen Rust thing, which is outputting these header files. So I have a header file, I have a static library. I'm now ready to link anything that can link C projects in. It doesn't need to know it's Rust. And that's what's happening here. We're linking the static library, we're linking the header file. And then basically, by nature of doing that, everything inside that like header file is now available on the C object, like on the C import, basically. So on the C object, I can import the types. And actually, this is even smart enough to sort of inspect the C type under the surface. So it kind of knows all these things exist. Kind of look a little bit horrible and mangled, but presumably this means if I was like to typo something, it's going to tell me it doesn't exist. This is actually pretty cool. I'm impressed by this. And so yeah, and so now let's just go back to the new one again. It's nice and simple, right? This is we're now in a state where we have a polar new method defined in the header file. The static library has the method defined. We can import that pointer. We have an opaque pointer to polar. We can call methods. It's like super easy. Exactly, yeah. Building a DLL and extern C and the no mangle. Why did I take it again? Lib.rs. And the no mangle to make sure the name doesn't get mangled. That's the other key point. So yeah, now we can just call into all of the kind of FFI stuff. And yeah, so this, there's a reasonable amount of like boilerplatey kind of stuff here, but there's a little bit of having to deal with like converting strings back and forth, because so there's kind of like one I'd say reasonably big gotcha with doing this Rust and Rust Go, or just Rust and everything interrupt, which is the Rust is really managing all the memories still. And even for things like strings, Rust is sort of managing the memory. And definitely for things like pointers. So you need to make sure that you're actually properly cleaning up and deleting, freeing your memory afterwards. So for example, we have a delete on polar FFI, which will do the polar free to go and free the memory, things like that. Okay. So I mean, we're kind of coming to the end of the hour. I think we've kind of covered the main pieces of everything that's going on. I'd kind of encourage and gladly take any questions or dive into more things that people are interested in. But I feel like we covered a lot pretty fast. We're going to make the recording available if people want to go back and watch this in like half speed. It's probably helpful to understand me a bit better. But yeah, this is kind of it. This is what it looks like developing the Oso languages, Oso host languages. You build a host, you do some reflection, you add this FFI layer, you link C, you're kind of off to the races. It's a lot of fun. Yeah, thanks everyone for attending. Thanks for coming and watching the stream. We'll try and do some more of these in the future. Yeah, if there are particular topics people are interested in going into, you can go into the Rust code more. It's 11 p.m. there. That's awesome. Thanks for joining us even that late. I'll definitely do them more often. Have a good day too. What else do we have going on here? Explain SLG resolution. What is SLG resolution? I'm just going to Google this. SLG resolution. This is how we decide like ordering of what rules to execute and things like that, and the filtering, I think, is what you're referring to. So yeah, correct me if I'm wrong, but I think what you're referring to, I maybe don't know it by the formal name, is like how we sort of decide things like ordering of like rules like this to do, maybe. Like how we decide which of these to call into, which order we do things in. Is that what you're asking about? No, it's too late. Questions asked now. That's it. I'm gonna have to do another hour. No escape. No escape. But yeah, that would be a really great one to do as a follow-up. There's some really interesting stuff we had to do to make it work, so that basically there's two mechanisms we have for things like rules. One is like, how do we choose whatever, or maybe this is like a project or something. How do we decide which order to evaluate rules, and how do we decide which rules to do? And because of the like back and forth nature I spoke about, by that we need to like ask Go, is this thing an expense or not? That happens during that process of like sorting and filtering. So we have this kind of like asynchronous sort where we're like you compare two things. You then like pause the VM, wait for the Go to respond, get your answer back, and continue your sorting algorithm. And then similarly with filtering, we kind of like need to do these passes where we go through and do a bunch of stuff up front. That's a fun one, but that's more like a 5-hour live stream, I think, than anything. Okay, well, I'm not seeing any other questions, so thank you everyone again for joining. I'm gonna stop sharing there. Oh, I should probably advertise some things, shouldn't I? What do we have to advertise? I'm gonna see, how is Go coming along? Yeah, thanks, Steve. So you can see, thanks to Steve into Steve's. I'm gonna share my screen again, actually. Let me take this link. You can now go and get the 0.11 alpha version of the Oso Go library. Oh, look at this with documentation, everything. This is beautiful. So you can basically see the code I was just using. You can go and try it out. It's now available. Go get OSHQ Go Oso. And yeah, we'd absolutely love to get any feedback on it. Other things, if you haven't yet seen the Oso docs, I'd very much recommend them. docs.osohq.com. There's a bunch of helpful links from there, right? So you can go and find our like Oso community Slack and stuff like that. Which, yeah. Yep. There we go. Thanks, Steffi, in the Slack. Join slack.osohq.com. Cool. Well, that's all from me today. Thanks everyone for stopping by, and hope to see you again soon.